Okay. Okay. Yeah. The thing I wanted to talk about was regarding the Java IO package. This week, you are learning serialization. And I wanted to say a few things. I'm not going to get overly technical here. That is not the issue. That is not the point. That is not my goal. I am going to talk about some approaches that I find very interesting about the way they have designed the Java IO package, something that we can learn from. And that is what I want to talk about. So let me go ahead and share my screen. Okay, if you look at the package java.io, it is very confusing. There are so many classes and they are meant for doing communication outside of the Java virtual machine to maybe disk or network or so many other entities outside of the Java virtual machine. So your program is here and the JV, so you're in this virtual environment, your program is executing here in the Java virtual machine or on the Java virtual machine. And there are lots of other things outside. Maybe there is a remote server, there may be disk, there may be other things in memory, perhaps some other memory location from which you could get data. I don't know, I'm just imagining. Then maybe a printer, a lot of stuff, right? So normally when you read and write objects, you are, most of the time, you are dealing with stuff here, right? So what if you want to go here to the disk or go to a server or some other machine, remote machine, or even to another JVM? You are running two Java programs on the same machine and you want to communicate with the other program, right? So for those things, this java.io is very useful. But the sheer number of classes and um, their documentation can be very difficult to understand. So I am trying to give you a sense of how they have approached this issue that makes it easier for you to understand their design and also learn from that in constructing your own classes in the future. Okay. So first, let's talk about serialization. Okay. So serialization means you have a number of objects created in your program, a large number of objects perhaps, and you want to send these objects outside. So maybe there is a machine outside, far away, and you want to send all these objects to the other machine. And so there is a communication path, a line, and all these objects have to be shipped. And you know that they have to go as a sequence of bits, obviously, right? You have to ship all these objects as a sequence of bits. And once these bits arrive, thousands of bits perhaps, when they arrive at the other machine, you need to be reconstructing all these objects. So if you have 6 objects here, you need to get those 6 objects back at the other machine. Or you might say, that is not quite what I want to do. I want to put all these objects on disk. So you create a sequence of bits here, and this sequence represents these objects. And at a later point, maybe a few days later, you want to read these bits and then reconstruct all these objects. So this is today, and maybe tomorrow you want to read all these. This is all gone, all right? These things are not there anymore. This machine is gone. This Java virtual machine, I mean, and your program has quit. And tomorrow you read all these and you want to reconstruct those objects. Okay. That is what serialization does. What you do today to convert these objects into a sequence of bits is called serializing. And the process of converting these bits back to the objects is called deserialization. So the Java serialization mechanism has a way of serializing and deserializing. All right. So your objects may be very complicated. They may have all kinds of references with each other. All of that stuff, all of the data, their relationships, everything is preserved in the sequence of bits that you store here. The sequence of bits that you store when you store or you generate, when you serialize these objects, there is enough information here to reconstruct the objects. For example, if this is of type course, and if this is of type section, somehow, and I have no idea about the details of this. I think it is very well hidden by Java. The structure of these objects is preserved here. For example, there might be some information that says this is from a course object. This might say this is the course ID. So somehow it has to have some way of representing all this information in the sequence of bits, the type of the object, the values of the fields, and so on. And the deserialization mechanism looks at the type, interprets the rest of the bits based on the type and so on. Okay, I don't know the details because I haven't found any documentation on how they actually do the serialization. Right, and so I can't say much more about how they actually carry out the serialization, deserialization. But what we need to have is, if you want to have a course that should be serialized, you have to implement the serializable interface. And it is pretty painless because there is no method in serializable interface. You just need to write your code as before. There is nothing extra to be done for the most part. Of course, if there are, there could be some situations where you may need to do more. For example, if you have a static field, that doesn't get serialized. It doesn't become part of the serialized version. If there is anything that is not serializable here, then the serialization fails, it crashes. For example, let's clear this. Suppose I have two classes, section, class section, implements serializable, and class course, and I did not say it is serializable. Let's say we have string name, course C1 or C maybe, right? I don't want to write too many things. That's why I'm abbreviating here. Now, section is serializable. String is a serializable class. Okay. That is a piece of information that you get when you look at the documentation. But look at course. C is of type course, but I did not make it serializable. There is no serializable specification here. It doesn't say it is that course is implementing serializable. So if you try to serialize section, it will be able to serialize this, but it will crash with a non-serializable exception here for course, because course has not been serialized. So you have to put implement serializable here too. Since this is something I created, I can go ahead and modify this. But there could be a class here like point2D, which is a Java class, and this is not serializable. And I don't have any way of serializing this. So this would cause a problem. If section had a point2D object, I don't know why a section should have it, but anyway, suppose it had it, then this will crash the serialization mechanism. And the reason would be that point2D is not serializable. I have absolutely no way of making point2D serializable, but there are workarounds which we will see later. Okay. So let's talk about the concept that I wanted to really emphasize here. I wanted to have this as a prelude before we did this. So if you want to serialize something, what you need to do is create an object, object output stream. And let me abbreviate by saying OOS equals new object output stream. And you need to put something in parameters here. And you can write OOS dot write object and put an object here that will get serialized. So if you have a collection of section objects, if you have a class object, whatever, you put that object here, all of them will get serialized, provided there are no non-serializable stuff here. Now, what do you give as a parameter here? Well, if you look at the constructor of object output stream, you will see some options. And this class allows you to serialize. Without this class, you cannot serialize. But where does that serialized data go? That is actually a different problem altogether. That is what I am talking, that is what I want to emphasize here. You have objects and you have the serialized version. So that process of conversion from objects to serialized version is done through object output stream. Without that, there is no serialization. So that is a class. You create an object of that kind and serialize all your objects using that. But where does this go? Where are you going to store it? Do you want to store it on disk? Oops. Okay. Do you want to put this on disk? Or do you want to do that? Or do you want to send it to a remote computer so that it goes through a network? So this is one problem, serialization. Storing data on disk or shipping data to a remote location, that is a different problem. So that is what the Java designers have done. They have split the problem into two parts. One is actually the creation of the data. The second part is finding a destination for it. They are actually two different things. So for cohesion, they said, okay, let's see the purpose of object output stream is to actually serialize things. Where does the serialized data go? That is a different problem. We can send it to disk by using a file output stream or something like that. Okay. So that would be a different type of object. Using a second type of object, you take the serialized version and ship it to the disk, or maybe using some other class, you can send it to a remote machine. So see that separation of concerns. One is actually creating the serialized version. The other one is taking some data and shipping it to some place or storing it in some place. Shipping it to a remote location is different from storing it. So there is a class C1 for this. There is a class C2 for this. But the same object output stream can be combined with C1 to get the serialized data to go to a remote location, and object output stream can be combined with C2 to send the serialized data to disk. So you should appreciate that design here. There is a file output stream that we create. I think it is in one of the examples. That is only to create a disk file. But the creation of the serialized data is done by object output stream. So this object output stream is combined with file output stream to create a pair that takes an object and sends it to disk. So when you look at the java.io package, you should see that there are some classes that would actually deal with disk, and there are some other classes that actually take data and then convert it to some other form. So you can combine these classes in interesting ways to get different behaviors. That is what I want you to emphasize, that if instead of doing it this way, if you were to have all kinds of combinations as classes, that would be a real class explosion. Okay, instead of say 7 plus 6 classes, you will probably have 7 times 6 classes. For every class here, if you want to add the functionality into this class, then there will be 7 times 6 classes. You don't want that. Instead, you can keep the number of classes to a smaller number if you separate out the concerns. So that is what I wanted to tell you regarding java.io. Any questions that you have? All right, then let me go ahead and stop recording because I don't have anything else to emphasize here, because I think this is a concept that is worth really thinking about. That is, every class should be dedicated for one particular purpose. Okay, that would make design more understandable and more flexible. Any questions? Okay, let me stop recording here then. I will